Hello, everybody. So this is your solving proportions project. I'm actually really excited about this project. There are some edits I had to make to it to make it clearer, and I also wanted to make this video to make it clearer for you to complete. Now, what I'm going to do in this lesson is pretty much go over pretty much the entire instruction, and then all that will be left for you for this project is to complete one problem and then answer a few questions in your own words. So this project is very, very short. It won't take too long to do after you watch this video. The important thing is that you listen, you ask questions if you have any. So at this point, I'm going to get started. So we're going to talk about what proportions are. A proportion when two ratios are equal to another. Okay, so take a look at this. We got two fractions equal to another. Remember, a ratio can be a fraction. So 1 to 2 equals what over 4? Many of you can answer this pretty easily. So when you have two fractions that equal one another, basically what that means is you're going to multiply both of them by the same, both the top and the bottom, the numerator and the denominator, by the same number. So if we turn 2 into 4, what do we have to multiply 2 by in order to get to 4? 2. Simple enough. So that means if we multiply this by 2, we have to multiply the top by 2. 1 times 2 is 2. So the question mark is 2. That's the answer. As you can see, we got it because we multiplied the top and the bottom by 2. We multiply the top and the bottom by the same thing in order to get an equal ratio or fraction. In case this doesn't make any sense, what I'm going to do is I'm going to show you a visual. Okay? This is the visual. As you can see, 1/2 is equal to 2 over 4. They are the exact same fraction of that whole. They're exact same part of that whole. They both cover half of it. 1 over 2 is the same thing as 2 over 4. So this makes sense. Now, there are 3 ways to tell if ratios are proportional. Remember, ratios or same thing as fractions. They're just a comparison of two numbers, 1 to 2, 2 to 4. Now, 2 ways to tell. Number 1, you can divide each fraction going down to see if they equal the same thing. So if we divide going down, we have 1 divided by 2 right here. This is 1 divided by 2. So if we do that, what we'll see is 2 goes into 1. 2 can't go into 1. 0 times. 2 times 0, 0. We subtract. We're left with 1. Now to continue this, we got to put a 0.0 after it. We drag down the 0. We drag up the decimal. 2 goes into 10. How many times? 5. 2 times 5 is 10. And we're have nothing left. So the answer here is 0.5. 1 divided by 2 is 0.5. So let's see if we get the same thing over here, which we should because these two are equal. So 2 divided by 4 equals, well, let's figure that out. If we have 4 going into 2, 4 can't go into 2. So that's going to be 0 times. Multiply 4 times 0. We get 0. 2 minus 0. We're left with 2. And then we have to put a decimal 0 after it in order to keep it going. Drag down the 0. Drag up the decimal. So 4 goes into 20 5 times. 4 times 5 is 20. We have nothing left, so we are done. As you can see, it also equals 0.5. So this is 0.5 right here. Remember to write this down on your paper to get all the credit you deserve. So as you can see, we divided going down of both. They equal the same thing. That means they are proportional. This makes sense because the line actually means divide. So 1 over 2, not only is this a fraction, but this is also 1 divided by 2 or 2 divided by 4. They're the same thing. Now you can pause this video if you need to write this down, but I'm going to move on. There's a second way to tell if ratios are proportional. Divide going backward. Okay. So there is a reason why this works, and I'll show you. So if we divide going backwards, that means 2 divided by 1, which equals 2, okay? And let's see if we get the same thing over here. 4 divided by 2, that equals 2. So as you can see, when we divided going backwards on the top and the bottom, the numerator and the denominator, we got 2 for each. The reason this makes sense is the opposite of dividing is multiplying. So if we multiplied going forward by 2, we would get 2 over 4. So this makes complete sense. It works. Multiply by the same number going forward, get the second fraction, divide going backward, get 2. Either way, that will tell you if the proportion is proportional, if the two ratios are proportional. Okay, so there's one more way that we can use. Number 3. This is my favorite one. We cross multiply. This is called the butterfly method. If we cross multiply, what we're doing is 2 times 2 right here. We're multiplying 2 times 2 right here. That is 4. And then 1 times 4, which is 4. This one's my favorite. This is the butterfly method. If we cross multiply, we multiply going diagonal and we get the same number on both sides, that means it is proportional. Okay? So let's say we do this butterfly method and we don't get the same number on both sides. What that means is it's not proportional. This doesn't work. They're not two equal fractions. Okay? Let me show you an example of this. Yep, 4 on each side. Okay, so here are two fractions that are supposedly equal to another, but we need to find out if it's true. Are they equal to one another? Well, let's see. You can try one of the 3, but I'm going to do my favorite right here. 5 times 12. That's 60. 11 times 6. That is 66. As you can see, they're not equal. So this is not proportional. Not proportional is what we're going to call it. Now, you could also find it out a different way. You could have done 5 divided by 6, saw if it was the same as 11 divided by 12, wouldn't be the same number. Divided going backward, 11 divided by 5, and 12 divided by 6. 12 divided by 6 is 2. 11 divided by 5 is not 2. So these are not proportional. You have to get the same number for each. I'm always going to be using number 3. That's my favorite method. It's easy, and honestly, I like how it looks. It kind of looks artistic. I like the drawing that I make here. Looks pretty. I like it. So yes, these two fractions are not equal because we did the butterfly method. We cross multiplied, and we did not get the same number on both sides. All right. So now I want to move on to something a little bit more real world. So we're going to transition away from just looking at numbers, and we're going to do some real world thinking. So why do we need to know this? Why is this important? That's the question everybody asks. Why? We can use proportion to solve many different kinds of real world problems. For example, one thing I like to do in my free time is I like to go on maps, and I just like to zoom in into random places that I've never been before. These two houses I found on a remote island in Alaska. So I found these I found these houses, and I like these houses. They're on a remote island in Alaska. Let's say I wanted to build my own, but they're too large and I don't have enough building material. So I want to build the same exact houses, but smaller. Okay. So let's say I build the first house. Okay, there's the first house. You'll see how it's smaller than the one on the left. So on the one on the right is smaller than the one on the left. So I made the one on the top, and it's smaller. So my question is, the second house, how big is that going to be? Okay, we got to use proportions to figure this out, because they're both got to be shrunk the same amount. We can't have this one the exact same, the one on the left, the exact same size as the one on the right, because they both have to be shrunk the same amount. They got to be proportional. We can't have them different sizes related to one another. So what do? We put them in fractions. So now you see it's a fraction. Two equal fractions. We have a problem here. So if the first house is 250 square feet on the island of Alaska,
and the one on the bottom is 175 square feet. And then we make a new model of it, right? We shrink it. So we shrink the one on the top from 250 square feet to 150 square feet. How much are we going to have to shrink the one on the right to? Now, there is somebody in class who said, oh, we just subtract by 100 because 250 minus 100 is 150. And so we would have to minus 100 by this. Well, here's the thing. That's wrong. Okay? Remember how we do proportions. To make them proportional, to find out if it's proportional, what we like to do is use the cross multiplication method. Okay? So I'm going to delete all that because that is wrong. Okay? This is different. When we do fractions and we have two equal portions, we have to use multiplication to figure it out. So what I'm going to do is I'm going to use the butterfly method. 250 times what we don't know, okay? This question mark, we don't know. So if we don't know it, what do we replace it with? A variable, a letter. I'm going to put X. You can put any letter you want. All right? Now we got to do 175 times 150. For this project, I'm going to let you use a calculator to make things faster, okay? That is something I usually don't let you do in this class, but this is a different kind of project. So what I'm going to do is I'm going to go into my calculator right now on my phone. And I'm going to look up 250 times X. That one's easy. 250 times X, that's 250X. Remember, if you're multiplying a number by a letter, you just put them right next to each other. This is 250 times X. And then right here, we have 150 times 175. So I'm going to type in that. That is 26,250. Okay, remember we got to drag down, or in this case up, our equal sign. So now we know that 250 times a number is 26,250. So to figure out what the variable is, we got to do the inverse. So we're going backwards. When we go backwards, we're going to start with 26,250. Once we do that, if we're going backwards, we got to go with 250 next. Now 250 is right next to X. If a number is right next to a letter, that means we are multiplying. So the opposite of multiplying is dividing. We're dividing by what? 250. And that's going to get us what X is. So once again, you can use your calculator for this. 26,250 divided by 250. Let's see what we get. Okay, 105. That's your answer. So in order to make this proportional, this has to be 105 square feet. This is something you should be writing down. You should be writing down how we solve this. Okay. So let me go over this for a second. If what we see on this island in Alaska is two houses, one 250 square feet, one 175, and we want to shrink them to be the same amount of shrunken, it should be 150 square feet over 105. You can actually double check this. So in this case, if we use the butterfly method, now it's 250 square feet times 105 square feet. If I use my calculator, I will see that 105 times 250 is 26,250, which is what we had for 175 times 150. So this is proportional because when we do the butterfly method, they both equal the same thing. So they both need to be shrunken the same amount. And so that's exactly what we did. All right. If you need to go, you can pause this if you need to write it down. But right now I'm going to move on since it's a video. All right. So let me give you another example. For all you artists out there, my mom is an artist. She's a portrait artist. She hates math. But the thing is, in order to be a portrait artist, you need to know proportions. Why do you need to know proportions? Well, the thing is, let's say you have a picture like the one on the right, and you want to draw this picture. Well, the thing is, if you want to draw this picture, you're going to need to know proportions, or otherwise what's going to happen is you could draw your head too big or too small. The nose could be too big or too small. You could put the eyes in the wrong places. It'll just look wonky if you don't use proportions the correct way. For example, I have a paper here that is 10 inches. This is the picture. It's 10 inches tall. Okay. So I need to convert this picture that is 10 inches tall into this picture, which is 8 inches tall. Okay. So what I need to do is, since the paper is shrunken, I need to shrink the head the same exact amount. So how do I do that? Well, you got to use proportions. Sorry, all you artists, you got to use math in order to do art. So let's set up our proportions. 2 equal fractions. Remember, that's what we start with. So let's create what we have to do. So we have 10 inches. That's the paper. So the paper is going to go on top. No, that's the, yeah, that's the paper. Okay. Or the frame, if you want to call it the frame, that's fine too. And then on bottom, that's 4. So it's 10 over 4, and 4 is a head. That's the head we're drawing. Okay, so this is for the picture. Okay. Let me make sense of this for you. The picture is on the left right here. The picture is 10 inches for the paper. Paper is 10 inches tall and 4 inches tall for the head. So now we need to convert this over to the actual drawing. So here's the drawing. We know the drawing is going to be on an 8-inch slab of paper. So the paper is going to be 8 inches. What's the problem? Well, we need to figure out how tall we need to make the head. How much do we need to shrink that head in order to make it proportional? Now, somebody said, oh, you just got to subtract by 2 because 10 minus 2 is 8. So if we do 4 minus 2, that's going to be 2. Here's the thing. That doesn't make sense. We can't just subtract the 2. It's not going to create an equal fraction. For example, if it was 8 divided by 2, and we made this 2, that would be 4. But a 10 divided by 2 does not, 10 divided by 4 does not equal 2. So these are not equal fractions. We need to create equal fractions for it to be proportional. The reason we got to do this is because if we did 2, our head would be too small on the paper. So why don't we use the butterfly method in order to figure this out? Okay. So butterfly method, 10 times the question mark. Question mark is what we don't know. If we don't know it, what do we got to replace it with? A variable. I'm going to use X. You can use any letter you want. 10 times X. That's easy. That's 10X. Remember, if a number is multiplied by a letter, you just put the number right next to the letter. Then we do 8 times 4. 8 times 4 is 32. So drag down the equal sign. Cool. So we have 10x equals 32. What that means is 10 times what is 32. So how do we do this? How do we find the letter? How do we define the variable? We got to do the inverse. So we go backwards. We start with 32. Once we start with 32, instead of multiplying by 10, we're going to divide by 10. 32 divided by 10, which equals X. Now you can use a calculator for this. That's fine. But I'm going to do it on here. So 10 goes into 32. How many times? 3. Because 10 times 3 gets us the closest to 32, which is 30. What's going to be left? 32 minus 30. That's 2. What we got to do to keep this going? Decimal 0. Drag up the decimal. Drag down the 0. So it's 10 goes into 20 2 times. 10 times 2 is 20. And we are done. So that means X is 3.2. What does that mean? Well, if we are drawing it on this paper, we need to shrink the 4-inch head right here, and we need to make it 3.2 inches. Again, this is also you make the most accurate picture, okay? You don't want to be hired as a portrait artist and then your proportions are all wonky. You're going to make the head too big or too small, depending on what mistake you do. If you even try to use your eyes to make them accurate, it doesn't work all the time. We are not perfect. So math helps us to get it perfect. All right, I'm going to move on. If you need to pause this to write it, that's fine. All right, who else needs to use proportions? Oh, chefs. Chefs need to use proportions. I want to make this cake, but I don't have enough flour. The recipe calls for 2 cups of flour. Take a look at that. Okay. but I don't have enough flour. Well, how much flour do I have? Let's see. Okay, let's figure that out. 1 cup of flour. Okay, I only have half the flour I need. That's a problem. So if we only have 1 cup of flour, we can't just put 1.5 cups of cocoa powder, because then you're just going to get a really chocolatey cake, which is usually fine, but it doesn't have enough flour, so it's not even going to bake correctly. It's probably not even going to be formed correctly. It's probably just going to be a lot of soup. It's not going to rise. That's the problem. We don't have enough flour. So what we need to do is we need to make the 1 cup of flour proportional to the amount of cocoa powder. So we need to create a proportion, which is 2 equal fractions. There we go. So if we have 2 cups of flour and 1.5 cups of cocoa powder, the problem is we only have 1 cup of flour. How many cups of cocoa powder are we going to need? We shrink this from 2 to 1. So what we need to shrink 1.5 to is what? That's what we need to figure out. How to figure this out? We use the butterfly method. 2 times a question mark. Question mark. We don't know what this number is, so we replace it with a letter, x. So this is 2 times x, which is 2x. And then we have 1 times 1.5, which is just 1.5, because anything times 1 is just that number. Set them equal to each other, bring down the equal sign. Okay, now the question is, 2 times what is 1.5? How do we figure that out? We got to do the inverse. So we have 2x equals 1.5. In order to find the letter, we got to do the inverse. So we go backwards. We start with 1.5. And instead of multiplying by 2, we're going to divide by 2. So 1.5 divided by 2, and that's going to equal x. All right, let's do 2 goes into 1.5. Let's try that. 2 can't go into 1. 0 times. So 1 minus 0, that's 1. Drag up that decimal. Bring down the 5. So 2 goes into 15 now. 2 can go into 15 7 times. 2 times 7 is 14. 15 minus 14 is 1. So what do we, so we got 1 left. What that means is if we have anything left, we just got to add a 0. Now we don't add a decimal 0 because there's already a decimal. Drag down the 0. Now it's 2 goes into 10, which is 5 times. 2 times 5 is 10. Look at that. We got nothing left. So we're done. So the answer is 0.75. So what does that mean? I'll show you what that means. That means if we want to make this recipe, but we only have 1 cup of flour, in order to make it proportional and even, we have to have an even cake. We can't have not enough flour, but the same amount of cocoa powder, because it's not going to bake correctly. That's going to be a nasty cake. Trust me. Have to be 0.75 cups of cocoa powder. Now, if you used your calculator and you did 2 times 0.575, you would get 1.5, which is the same as 1 times 1.5. So if you do the butterfly method, you will see that it's even. Okay. If you need more time, you can pause it. I'm going to move on. Now, here's where we get to the meat of this project, okay? So the thing about this project is I really wanted to do this, and the main reason why is because what I'm going to teach you how to do is use proportions in order to promote social justice, in order how to promote equality in your everyday life. I'll give you an example of this. Word problem time. Are these 2 ratios proportional? Why or why not? Okay. For every 100 women in the US, there are 97.95 men. Some people might be wondering, why is this a decimal? How do you have a decimal amount of men? You don't, okay? This is if there are only 100 women and you averaged it out, okay? So this is just the ratio. This is like the percentage of men to women, okay? So this is a ratio. We have 100 women in the US and there are 97.95 men. So there are a little bit less men in the US than there are women. So what I'm going to do is I'm going to take these 2 numbers. So on top, clearly what we have is women, 100 women. And on bottom, 97.5, that describes men. So you have men on the bottom. Okay. And remember, a proportion for a proportion, you have to have two fractions that are equal to one another. So there are 144 women, 395 men. Okay. So 144 women, so that's going to go 144 right here. And that's going to go men on the bottom. And that's 395. Okay. So we set up our proportion. Now, this first fraction, this is talking about the US. This is women to men in the US. So this is describing the US. The next fraction, that's talking about Congress. Okay. So the first one is describing US, second one is describing Congress. The question is, are they proportional? How do we find out if they're proportional? We got to use the butterfly method. Now, if we get the same number when we cross multiply, that means they're proportional. We're good. If we don't, that means they're not proportional. Let me show you why this matters. 100 times 395. All I got to do is 395 times 1, which is 395, add 2 zeros. So the answer here is 39,500. Then right here, we got 144 times 97.95. I'm going to use my calculator for this. Okay. When I used my calculator, I got 14,104.8. Okay, drag down the equal sign. Are these two equal numbers? No, they're not. But most importantly, are they even close to the same number? No, they are way off. This is much lower than this one. So why is this important? Why does this matter at all? Here's why, okay? In the US, we have about the same amount of women to men. It's about even. It's very close to even. But in Congress, there are significantly less women than men. So what this tells us is that there's unfairness going on. Women aren't being represented fairly in Congress. If we had an accurate fraction or an accurate ratio of women to men in Congress, what we would see is the same amount of women to men in Congress. That would represent the US equally, because in the US, women and men have are about the same amount. There are the same amount of women to men. But in Congress, that's not true. We have pretty much over double the amount of men than women in Congress. Okay? So what that means is women aren't being represented fairly in Congress. I'm also at the park right now. So just so you know, some people are talking. It's fine. But what I'm trying to say here is you can use these proportions to see how unfair they're being treated. These two numbers are not even close to equal. So they're not even close to proportional. It's not even close to fair. As you can see, if women to men, it should be about equal, because there is an equal amount of women to men in the US, just about. But in Congress, that is not the truth at all. And you can see that by looking at these numbers. That's why we need proportions. That's why we need to understand this. Okay? So you can go ahead and write this down. We're going to do one more in order to nail this idea in the bud. Okay? All right, here's another one. We're going to use Congress again. So it's kind of like the same kind of proportion. We're going to draw two equal fractions. That's how we do proportions. Here's the first ratio. Circle the numbers. We got 540 members of the 117th US Congress. This isn't a number we got to worry about. This is describing US Congress. And then 62 are African American. Okay. So we got 540 in the first fraction. Second, and then under that, we got 62. Okay. So 542 is describing what? The members. So overall members. This is like the total. This is in Congress. There are 540 members of US Congress. And then, so this is overall. 62, that describes African Americans in Congress.
So that's our first proportion. This is talking about Congress, US Congress. So we're going to put Congress on top. This describes Congress. Now, the next ratio, what is that going to describe? That describes the US population. So this next one is just the US in total. Okay. In the US, 13.4% is African American. So 13.4% describes African American. So we're going to have that on the bottom because on the bottom number, that's describing African Americans. So what goes on top? Members. What is that referring to? That, again, that's our total. So if we're referring to the total, if we're talking about the total, if we're talking about a total percentage, the percentage that represents the whole, the highest percentage you can get, that's 100. Okay, so that's 100 over 13.4. The total, 100% over how many African Americans there are, 13.4%. So now what we can do is to find out if this is proportional, we can do the butterfly method. So 62 times 100, that's easy. That's 6,200. Don't even have to use my calculator for that. And then we got 540 times 13.4. I'm going to use my calculator for that one. And that is 7,236. All right. Drag down the equal sign. Are these two numbers equal to each other? No. It's not incredibly far off, but it's pretty far off. Okay, it's not the most equal thing that you've seen. Okay, it's a little over 1,000 off. So what does that mean? It's not proportional. Okay, so why does that matter? Why does it matter that this isn't proportional? Well, as you can see right here, hold on, not proportional. I'm going to write that right here. They're not proportional because when we did the butterfly method, they aren't equal. Why does that matter? Well, as you can see here, this number on the left is smaller than the one on the right. What does that mean? In Congress, right here, you don't have enough African Americans in the population to justify the US's population. In other words, there are more African Americans as a percentage in the US than there are in Congress. That's not good because what you want to see in Congress is the same exact percentage of African Americans as in the US. That would mean that everybody's being treated equally. Everybody has the same exact amount of representation. Okay. In Congress, there should be the exact same percentage of African Americans as in the US because the Congress is supposed to represent the US. So if we have about 13.4% of people in the US are African Americans, and 13.4% of Congress should be African American. It needs to be the exact same because the Congress is supposed to represent us, but clearly it doesn't because they're not equal ratios. They're not equal fractions, okay? These are not equal. So what you can see here is that there's a population being treated unfairly. There's a population that's not being represented fairly in Congress, and that is the African American population. That is the problem. And we used math to figure that out. We used math to figure out that people are being treated unfairly, that inequality is existent in Congress. Okay? All right. Once again, you can write this down, but I'm going to move on. Okay. So what does it mean if it's not proportional? So if the ratio of African Americans in the US is not proportional to the ratio of women or African Americans in Congress, what does that mean? Is that fair? Why or why not? We've talked about this. You can write it in your own words. I want y'all to give me a response in your own words. But the answer is no, it's not fair. Okay, there should be the exact ratio of women to men and the exact ratio of white to African American in Congress as there is in the US, because Congress is supposed to represent the US. All right. So I know this is dragging on a little long, but